Oh, hello there. I didn't see you there. I know that right now you might be having a lot of questions and a lot of concerns. It's a time of high panic. You might be thinking, how am I going to do math? Who will help me with my math? Well, I am here to reassure you that even though we aren't in school, your math instruction will go on. So, I received a message from one of our friends in Plainwell about using the sine of sums identity. And they asked me, Mr. Precalc, how could I do a problem that asks me to find the sine of u minus v when we know that the sine of u is equal to 3/5, and we know that the sine of v is equal to 4/5. Well, if we wanted to deal with a situation that looked like this, the first thing we'd have to do is recognize which identity we're using. So this is a sine of a difference. And we know that the sine of a difference can be rewritten as the sine of u multiplied by the cosine of v plus the cosine of u multiplied by the sine of v. And we know what the sine of u is. The sine of u is 3/5. And we know what the sine of v is. The sine of v is 4/5. But we need to know what the cosine of v and the cosine of u are. So let's take a look at how we would do that. If we know that the sine of u is equal to 3/5, then we could draw a triangle where we know that our opposite side is 3 and our hypotenuse should be 5, where we call this angle u. If that was the situation, then we would know, because this is a 3-4-5 triangle, that this side would have to be 4, and so the cosine of v, the cosine of u would have to be equal to 4/5. Meanwhile, if we wanted to find the cosine of v, we could use the fact that the sine of v is equal to 4/5. And if the sine of v was equal to 4/5, then we could use a 3-4-5 triangle again to find out that this side is going to be 3. And so the cosine of v would be 3/5, which means that our identity would end up looking like this after we input our values. So we would end up with 9/25 plus 16/25, which is 25/25, which just so happens to equal 1. And 1 is our final answer for this problem. Now, another person asked a question that involved tangents. And they asked us how we could go about finding the tangent of 5π/12. Now, 5π/12 is not a nice number from our unit circle, but it's made out of nice numbers from our unit circle. This is the same as asking, this marker isn't working very well. This is the same as asking, let's see if we can find a good one. What is the tangent of 3π/12 plus 2π/12? These numbers we like a lot more because 3π/12 is really π/4. And 2π/12 is really π/6. So, rather than trying to find this thing, we could try to find the tangent of π/4 plus π/6 instead. we have an identity for dealing with this, and it tells us, I had to look at what the identity was because my memory is terrible, that if I have the tangent of u plus v, it's going to equal the tangent of u plus the tangent of v divided by 1 minus the tangent of u times the tangent of v. So we need to think back about our unit circle. We know that the tangent of 1/4 of pi is 1. Tangent of pi sixth is a little bit trickier. Remember that pi sixths on our unit circle is right here. So this is a situation where we're at the square root of 3 over 2, 1/2. So if we were to take 1/2 divided by the square root of 3 over 2, that would become 1 over the square root of 3, which equals the square root of 3 over 3. And so this value is equal to the square root of 3 over 3. So I take the tangent of pi fourths, which is 1, plus the tangent of pi sixths, which is the square root of 3 over 3, divided by 1 minus 1 times the square root of 3 over 3. Now, one mistake that some people will make is they'll say that 1 minus 1 is 0. And if they do that, then they're ignoring their order of operations. Remember, we need to multiply before we subtract. So this actually doesn't really do much. We would just write it as 1 plus the square root of 3 over 3 over 1 minus the square root of 3 over 3. And there are different things we could do to simplify that, getting common denominators and stuff like that. But this gives you the essence of how this problem works. I hope that this was informative for you and put some of your fears about not having math instruction at ease. I look forward to seeing you again sometime soon. Have a wonderful day.